In the previous episode, I explained the whole setup here, and just a recap: on top we have everything that makes us human see the things how it should be, and in the lower part we have everything how the digital machines need the stuff to digest it wisely, and that for many reasons. Why is maybe important, but more importantly is that we just do it in the right way, and then we don't have to face the consequences of wrong data. But I want to give you, of course, one more short little idea why linear workflow is so important to us. And for that, I clean up here that for a moment. Two main things happened, of course, with gamma-based and 0 to 1.0 values, that we have an area where it works inside. And you remember maybe when I had here these three bars from R, G, and B in it, R, G, and B. And when we add to each of them the same amount, then the same amount is of course then always clipped here. Exactly this amount would be clipped. And if you save this, or if you have no concatenation in your mathematics, that means they don't put into account that something went wrong from the start, and you subtract then from these values here, because it's clipped the same amount, then you end up maybe here exactly, and everything that had before some values is then on the same level, which means in this case, extreme, I admit, it's just gray in terms of color. When there's no distance between R, G, and B, then it's gray. Just that simple, just as a refresher. But the main thing in gamma-based compositing, which we'd like to avoid like hell, is that when we have an input here from, let's say, one stop, that would be maybe here, this distance, then we can say we go here to the outside, and I have to do this here, vertical line, and this would be here the 0 point. So from this small area we go then to this long one here in the output. And when we think about this as input, what we get from a camera or whatever, and this as an output, then the area here is exactly our compositing application, where everything changes. So when this is all based on a curve, then for example this one stop, when I put this here, I hope I get the same distance here. When I put this up, we get already the idea. It has nearly no value here, and I need to go, oops. But you get the idea where I'm heading with that. This little stroke here is wrong. So let me fix that. Something goes wrong here on that point, sorry. So we see here already there's a difference. Same input here in terms of stops, but a complete different one. That is maybe what we had in mind in the first place. But now comes some changes here into it. Mathematical changes. Multiply and add and dodge and burn and overlay and whatever you think. And maybe just some other adjustments, maybe only in one channel, because the curve stands here only for R, G, or B. So when we move this now to the side, then you get already the idea that the length inside of the curve changes from this length here to this, and maybe then to this. 3 different lengths. And when we have maybe an operation that would go all the way up on the curve and then finally goes down, we end up maybe with only this length, because it moves then only this, and we get then as output, instead of this area, we get only this area here. This is in a nutshell, simplified, and maybe there are some areas where we could argue about all of that. But in a nutshell, any curve is critical in compositing. When we have a straight line, if that would be straight, we can see that this is the same distance as this would be here, and of course we can go over 1.0 because it goes wherever we want. And so we can move things up and down, and the idea of the distance stays the same. And then on the output side, when we go to the human part again, we can put in a gamma curve and we get the values that we want. So inside the machine, we need it linearized. That's the big part here. So I switch back to where we can. So with these only two little things in mind, just that was a simplified refresher, of course, I want to go now here in this field and find the places where things can go wrong or where we have problems maybe. And to do that, I want to start here just only in the eye area, because that is maybe the place where we find our first victim. And to do that, I have a new layer here, and I want to go then always in an empty field, discuss this, and then place this somewhere here on top of it and fade the background after a while out, so because I think it becomes very crowded here. The first part, when we have our eye area here, and I paint here the stroke because we are above it, and we get reference material. And reference is something that we all need because we can't know what we haven't seen before in life. And as 3D artists, we get all kinds of ideas from clients, from film studios, or so on. And when I say we all have never seen an explosion in space, then some might not agree with me. But when I say we never have seen face-to-face an explosion in space, in real, just when it explodes, then I think everyone will agree with me. We haven't. But we have an idea how that looks like and when it looks wrong. So why is that? Because we have seen a lot of movies, and after a while we see something that pleases our eye and our experience, and so we want to have, of course, everything in that way, or even better. Reference. When we get our reference from the internet, for example, we have maybe a baked-in gamma into it. That's maybe not really the problem, but maybe someone thought, it would look nicer if we go here just with a curve like that, because the dark and the middle part needs more contrast, and so I don't care about this area here and I roll out the highlights. Then another one comes along and said, okay, and I have no idea how to get this different than this. And this is a tone mapping. It is not expressible with one curve. It's for locally tone mapping. It's all over the place. Wherever a hard contrast it will be pulled out. And so when we add all of these together, we get maybe a picture that looks cool and that looks pleasing to the eye. And we think that's exactly the way it is. But on the end we get something that is maybe not exactly how reality works. And if photorealistic is our target, or something similar, then we should have something that comes in as this. And that is what I want to have. And I can control how I look to it. So reference gives us an idea, and we follow exactly what the reference gives us, more or less. And there is a big problem in it, because we start already out with something that we might not know, or we know it, but the image looks a little bit different, and so we tweak it without knowing where the source comes from. So the source is always something that is very important, and you should shoot it on your own. And then you get maybe an HDRI or a JPEG, and you add these on top of each other. And when you go then with the black and white level thingy that I have shown you in the exposure sequences, then on the end, when everything is white, it's maybe just here a dot, and the black one is also dot, no dynamic in it. And so you get maybe here something that has a lot of dynamic in the middle, and then it ends here. But on the end you get something out that can be calculated as a linear file. And this is then more or less trustworthy, especially when you have a chart in it with colors. where you have an idea what is finally a 50% gray value or 18% reflectance and so on, colors and so on. Then we have another problem. The gray card that we have in our image is always exactly, when we take a curve from a low dynamic range image, it's roughly here where our main interest is. And this depends highly on the light that we have on set and the exposure from the camera. So we can have that 50 or 18% in an image when the sun shines completely on it, or under a little street light in the night. We get these 50% based on our settings in the camera. So do we have now an absolute in our reference? No, not at all. And that is the next question. My idea is, if you really need an absolute value, you should have something like a light, like a flashlight with a diffuser in front of it, that has a very stable illumination source. And this should be in the picture, and you can measure this all the time. Because anything else that is just based on reflectance and so on is relative. And the moment you bring a light source in that is independent from anything else in the scene, you have the only fixed point in the scene. And that is maybe something to consider if you want to go that road. Normally, it's enough to go with the 50% gray or 18% reflectance card. So all of that, long story short, you have a reference that you need to trust. And when you have now trust in a reference, get more reference. And my advice, as long as possible, do your own resources. Get your own pictures. Then you know exactly what you have done. And if you have shot just something a year ago, maybe you can look into the metadata, because any raw image has that normally available. And then you can see which time you had, which ISO and so on. This gives you maybe not all, but a little bit. And again, HDRI is normally your friend. Even with 3 exposures, you get a more stable reference than anything else. Okay, this is only one little part, and I will shrink this and place it into our graph. All of this is now very similar to anything that we get here from the camera for our project, of course. The reference is just to get started. It can have maybe many things in it that don't work very well, but it's not produced most of the time for your project. But when you want to work with the project, we have to take a look what can go wrong here. It will be very similar, so I shorten this to make not too much repetition here in this episode. But let's have a look into that. This time I have here my little icon, the camera. It's just a symbol for everything that comes inside of our machine from the outside. That could be a scanner, that could be the camera, that could be a video camera, that could be film, many things. So, and the line is here. So we have, of course, a clear orientation where we move at the moment. When we're producing specially for our scene, again, we expect raw material, because JPEG can have baked in the camera response curve or the tonal response curve, and response curve, and it can have baked in a lot of other things as well when we take a look into gamma. And it can have in, and that is something very strong to consider, the color, the temperature of the color. Let's say 5500 degree Kelvin. And when we have, of course, the color already inside of our image, then it's a little bit difficult to get it out again. It sounds maybe simple that we can just adjust something, but there is a process where we have maybe 2 objects under a specific light source that looks exactly the same, but under a different light source, they look different. For example, a gray ball and a red ball under red light will look red in both cases. If we move this then under a green light, the gray ball will look green, but the red ball will look black. And this process, when we do something similar here, is sometimes not reversible or only with some losses. So the color temperature should be known and, of course, should match your project setup. That includes, of course, background footage and any other footage. Let's have a look what that could be. For example, when we have texture work. Textures are normally given in something where we have maybe no idea which temperature it had. We just take them and we assume maybe it was daylight. But daylight has not one color temperature. And the beauty of that problem is that when we have maybe here a graph and we have here maybe 3000 degree Kelvin and here 6000, to have maybe a wide span of warm, incandescent light and maybe an overcasted sky that goes in both directions, up and down. And then we get one color temperature, 5500. So what does it mean finally? It is only the middle point of an area. That could be here exactly that. But more importantly, when you have a vapor lamp, like fluorescent light or so, these have not just a nice curve around this point here where the middle point is the highest and then it goes nicely to the side, up and down. These curves can be, and I take this curve here away for a moment. Oops, I had this already. It can be that it starts here already and then has some spikes in it. And then it goes further, another spike, and fluorescent lights like this, for example. And then it goes here down and has maybe something like this. And the next fluorescent light, a room later, has maybe these spikes a little bit to the left, a little bit to the right. And this inconsistency leads normally that you have to pay for fluorescent light on set lots of money more than you would buy something for a supermarket to illuminate. And when you have to film in a supermarket, you get exactly this cheap stuff here, which is nice to illuminate a room, but for filming it is maybe not exactly what you want to have. So in these spikes here, when here is more the reddish part and here more the bluish part, these illuminate colors on your textures, of course, in a different way. More importantly, if you have maybe sunlight and some incandescent light, just a bulb here, and this mixes then one light, so you have no idea what light is all about here, and you get a texture that was maybe just taken with a little bit of fluorescent, a little bit with incandescent, and mostly with maybe reflected sunlight. So you get a lot of skylight, which is pretty bluish here, and it's mostly here in this area. And this texture then should work in your scene, where you have maybe also an idea how you want to set it up. Maybe just straight daylight, very neutral. But what is neutral finally? So you get already the idea. Just to have thousands of textures gives you not an option to get maybe the best quality, because you can pick from so many. The best quality is when you know exactly which quality these textures have, and if they have really a good balance. Then you have to think about the textures, for example, that even if captured in linear, where was the exposure? Is that exposure really balanced, that we have here maybe the 0.18 or the 50% gray? And when you know that at least these 50% or 18% is correct, but was there maybe a Macbeth chart available so you can do your own color profile if you don't get this in the best way, and you get everything exactly in one direction? And with the Macbeth chart you can do your own color profile and then convert it to the color profile that the project has. Very simple processes, very well supported from Adobe, but you need to have the right input. So it goes on and on and on with all of these, especially when you think about all these curves that I have painted, especially tone mapping, the big no for any project in the scene. And then when someone was maybe clever and wanted to have something very contrasty and said, wow, that looks cool. But anyway, with Gamma, with tone mapping, and with some clever ideas about to get textures nice, cool, whatever, this all will not work for your work, or you have to have adjustment, and that is sometimes not possible, like in the case of tone mapping. And tone mapping in terms of local contrast tone mapping. Global tone mapping might be available to fix, because then sometimes you have just a curve and you squeeze this curve down so it's just in the 1 to 0 or 0 to 1 value, and you just go over it back and it works maybe. Lots of speculation, not my major theme, of course. So all of that here goes into the quality finally that you get into the scene without having even started in your scene. Okay, let's have a look and put this card here into the hole. When we take a look, we have similar problems here in both areas, but the truth is, of course, as an artist in digital or in analog, we are 100% aware normally that we know when we look at something, we are dependent on the source itself, because we adapt to situations, we adapt to the context light, we adapt to many things, and after a while we can see even in a totally yellowish picture the whites again. Something like that. The computer don't care. If we don't adjust this, it takes the values as they come in. And so I have splitted this here, but again, it's pretty much the same idea, and it has the same problems when you have light sources that doesn't work, and you try to use light sources that can't be really simulated in 3D, like spiky fluorescent lights. Anyway, so we have two themes. The next theme would be, of course, then HDRI as image-based lighting, when we have set up, of course, our textures here. So let's have a look into that. The quality of an HDRI is, of course, highly dependent on the source that someone has used, and when we take a look, it's again inside of the machine area. And HDRI, as we have discussed this already, or HDRV for video, whatever we take, we need, of course, something that gives us certainty that the whole image was really well captured, not just with few little pictures with low dynamic range and then we have big gaps. And when we have two curves here from two JPEGs, for example, and the application would calculate then something between, you can't spot this normally, and I've shown you how they look when there's not a lot of motion between these points and when everything looks more or less grayish. Because when we have a nearly black point and a nearly white point here, then everything between is calculated to an average grayish value. Even if we have then, based on the exposure here, exposure there, a huge dynamic range. Some people, and if you meet those people, run, tell you can even create from a single exposure, maybe even from a JPEG, a whole HDRI. You only have to make 3 copies and push them up and down. Not working at all is, from my point of view, a big KO file when someone tries to give you such a suggestion. It's from my point of view considered just unprofessional. But you can use tone mapping applications to get these HDRI look exactly in that way, even with one exposure, because it creates only the local contrast or global contrast adjustments. That works to get a nice effect, but nothing that has any place here in 3D. And so the HDRI, you need to know which color temperature it had, because that's very important. Just to dump in everything in an HDRI app doesn't give you the right color and not the right Kelvin value. And we have discussed this before, so I don't go there again. But if your textures and the HDRI will not match. Maybe you have an incandescent HDRI and a daylight texture. That might cause trouble. These things should line up, and if you don't use them, even if you have everything linearized, there is a problem. And I would take really care that you get everything in the same way. So whatever light source is in the HDRI, even a very reddish one, you can have a daylight or a incandescent temperature in it. It's up to you, but make it in sync, have it in sync. So the next point is, of course, that you should have one measure point where the whole scene, if you have more than one HDRI for the whole scene, at the same position. Let's say you have maybe not the option to take in panorama, but you have a room here on set, and you want to have maybe the 3 walls that are there exactly measured, and you have some spotlights from the top, from the ceiling, and you just photograph the ceilings and the side walls. Each of these 3 separate images, separate HDRIs, should have something in common. So you don't have different values here for each side, because you don't have always the option to shoot a complete panorama. And sometimes it helps just to point from here, when you take a look from the top, from here or from here, with a fisheye, 180-degree in it, maybe just 5 exposures, and then you can compare those areas. Even if the fisheye gives you not enough resolution, it gives you a measurement, so you have a reference for all these 5 or 4 images in the space. Reference is always a good idea. So then there is the big question about the sun. How bright is the sun? The sun by itself is, of course, pretty stable. And the Earth by itself has, of course, some filters between the sun and the Earth, which change. Fat clouds, for example, represent a big filter. So the measurement here, how much you get here finally, is different. And this should be known. But how to measure the sun, or just give always a little dot into it with 1 million in the value? No, not at all. The idea is normally that when you shoot, for example, a chrome ball, you can shoot at the same time a gray ball. And then put a gray ball, which is just a diffuse surface, put a gray ball or a sphere with a gray material into your scene, illuminate with the chrome ball this scene, when this is here set to 50%, and have a look how much the gray ball image and the gray ball rendering differs from each other. You can put this in Photoshop, put this to difference, and the difference that you can see is then exactly what the sun should be. Then, and you have most of the time a panorama where the sun is somewhere, you can go with the lighting tool in Cinema 4D and place the light based on a reflection of a sphere. And where this light is, you can put then a real light, and you illuminate then the gray ball, and until the difference between the gray ball from the rendering and the gray ball from the reality has the same, so no difference anymore, you have to adjust the sunlight in your scene. And this gives you then, of course, also the option to have very hard shadows if you need this, or very soft shadows. You can vary with that. And you could put even a texture in front of it. As we have seen with the little Buddha figure, there were sunspots and shadow spots. You could manage to have then here something like a gobo, as it is called on set, before or after the light source. And then you get exactly your object that you place later in with the same light situation. Because image-based lighting has always a downside. The harsh light conditions are sometimes missing that you can have from a parallel light simulated in Cinema 4D as sunlight. I can't go here into the sunlight and the simulation of it, but I wanted to give you that little option to finally balance out the missing maximum sunlight in HDRI, because that would afford that we go here beyond any measurements, and the amount of shoots that we have to take for an exposure sequence would go really up to the sky, literally. Okay, so this and all of what I have said for reference and for textures goes here, of course, for the image-based lighting source, the HDRI. All of these three should match if possible. At least texture and HDRI for image-based lighting should match. And of course, the same happens if you use that HDRI for reflection. It should work in the same way because the reflection works finely scene-based. That sums it up roughly for the HDRI as input as light source. Let's have a look to the next point. When we take a look to gamma curve pictures, and sometimes we don't have the gamma inside of a color profile, it is baked in. And then we have no idea what finally happens to the picture. Maybe it is even more distorted. That's maybe not the biggest problem by itself. This goes into the scene, and then we have something in the scene that has that curve. And think of it maybe like something, we have a picture frame in the picture. We have a light source that goes to it, and we take a look about radiance or irradiance lighting with image-based and all of that. So any pixel here on that picture has a value based on this gamma curve, and it rays then light to the scene from there, because anything that receives light from a light source acts then, when we have global illumination, as a light source on its own. When it has a gamma curve in it, it reacts differently as it would have if it has just a linear light version in it. If cinema is not able to pull this gamma curve out, or whatever happens to the picture before, that might happen, for example. So if we have then the light inside of our nice linear space, banded, let's take this term for example, banded with the gamma curve of that picture. So anything that falls now in terms of light here has then a gamma curve in it, practically, because it can't be exactly the same as it would be if it had just a linear curve in it. So then we take this picture and we want to present this then over the line to an audience, and to make that visible we place, of course, another gamma curve in it so it can balance out what we had in the other way around. So we add practically twice the gamma curve to it, not knowing that we had that in. And the downside is maybe even worse, because we see this here then in our test renderings, and we adjust values, maybe this light, to it. Other areas that has maybe no gamma curve in it get then a different light, and the result in terms of light bounces from one to the next changes as well. Most of the time it might happen that the linear and the gamma based image will give me here something average in terms of light, so I have no problem on both sides. But then I have distorted my whole workflow, so I have something between a gamma curve and a straight curve, something here between, and we consider then the result as linear or gamma based, but not between. And then the next one, who makes maybe the color correction, assumes that we have something and starts over again, tries to get this out, and so on. And when you take in account that we have an HDR for image-based lighting, we have textures in it, and we have maybe background pictures, background images, all of that together gives me then, of course, something that will not work at all. It's a mixture. And the artist itself, and there we go over the line again, it's a little bit small here, the artist reacts on that and adjusts like hell in the scene to make it somehow possible that it looks right. But in the moment we have images with values in it where we have maybe just a gamma curve, and when the highlights are rolled out a little bit, so they don't go here up to the top, they go just smoothly out, then this will not really give me in the scene the right light when it moves in terms of motion blur and so on. So maybe I increase here the values a little bit to make that more visible, and so on and so on. I think you get my point. In the moment I start to give something wrong into the whole scene, I react on that as an artist, because I have to make on the end an image that looks believable. And the more I have flaw parts in it, not so good qualities in it, the more I have to tweak and to work on it to make something nice out of it. But the more I do it, the more I contribute to a distortion inside of the whole scene. I don't think that this is a good idea. And this is pretty much the whole core where I after with this series here. In the moment you just have everything in linear light and everything in the right color temperature and everything in the light level, that means you have one point where you orient all the other parts to it. That might be in the simplest way a 50% gray card, or the reference light that I suggested, which is normally not in use. Gray card is the one that everyone takes. Then you get something that works maybe toward an overall unique goal, because everything works together on a similar level. This is pretty much where we are after. And this is already pretty much what I have to say about. I think you got the core idea transferred where I wanted to bring you with all my discussions about the curves and all of that. It needs to be from the start pretty pristine. Otherwise you try to balance out something that will not work in the first place, and you get never really the quality that you want. Of course, on the end you go and put maybe just an S-curve on everything and it looks maybe nice. So lots of material to think about. It's always the same. Good in, good digesting, and good out. And of course there's one more thing that I want to discuss, but it follows pretty much the same, so I will try to make it very short. We have seen that when we take an object into the scene, we want to have a texture on it. And of course, we have to set up this texture on an object with some other settings. And this can be a shader, and this can be just the material by itself. Inside of the material settings, we can run into trouble as well if we don't use the diffuse, for example, and we put everything in the color channel instead of splitting it wisely up to be prepared for changes or for something that looks natural. So most of the time the materials are just set up by eye, which means that is a reflection or a reaction to what we have in a scene. And what we have in a scene, we have seen before. It can vary in quality, so the materials by itself can have quality issues based on what you have seen before. Textures, material, shaders, and so on has a huge influence to the scene. The light by itself can be image-based lighting, or it can be just lights that you have as objects in Cinema 4D, and you set these guys up based on maybe reference material and so on. So HDRI and of course the light objects have an influence to it as well. We have already a lot of things that can change. And then when we think about, when here would be the camera on a tripod, of course, and we have our object here, then we want to have maybe something in the background if we don't use just object buffers and compose the background later on in. Sometimes it's very useful to have a lot of background in it when this material would be, for example, glass, and we need the refraction of it. That's not really the strength of a compositing application to give you that, especially reflections, refractions, and so on. So this here could be then, of course, just an image. And I don't want to start here again with all my curves and the horrible tone mapping and maybe just the S-curve, or normally in this way, whatever you have here in terms of curves, and of course the color, temperature, very important. Then the brightness 50% and so on. So we have already another area where we can run into trouble. And some even suggest to go with an low dynamic range image from 0 to 1 or 100%, whatever you like, into the background. And then the real trouble starts, because anything from that background that goes through a class object or is reflected will give you no information for motion blur or depth of field blooming. That's pretty difficult, as we have seen when we started this series here. So there's a big no from my point of view to have in the background a low dynamic range image. That's something that makes no sense. So then some people would think, okay, we take an HDRI, we tone map this, and then we give this insight, because then we have everything in it. Nicely rolled out highlights, and toe and shoulder is nicely balanced, blah, blah, blah. Doesn't work at all, because we would reflect or we would react then with all these parts again to what we have in the background to make it to something that looks harmonic, in sync, in many ways, as we have seen here. So the background, if we have to place it inside based on some dependencies, has to have the same quality, 32-bit floating point, and has to have the same care when it is captured. Because when we just put something into an OpenEXR file, as I've said this before, OpenEXR is just a container. It doesn't make anything to just a linear light file. If you have a baked-in gamma in the whole pixel values and you just wrap it up into an OpenEXR file, means you save it out from Photoshop, for example, into that, it will have that inside. And then no one knows what happens, and then you get the biggest chaos ever. So everything in a scene, and I get not tired about this, everything has to follow the rules of the linear light. And the quality is always based on the smallest, weakest piece in the chain. Whatever you have in a scene, even a material, have an eye that you set them up based on everything else. But it needs to have the best quality, of course. Okay, that really sums it up. I think I could talk about this much longer, but I think you get the point, and I only wanted to encourage you to think about. It's pretty much impossible to give in that medium length course all the data ever needed for compositing, 3D, and capturing. But to get an idea what you need is maybe very important. So I like to place this here, but the real place would be here, of course, underneath. But there's always something between, and in the moment you react to something, it's on the line here. So to wrap it up, and that was a long one, I want to leave only a comment about this connection here. This is pretty stable as long as it is in linear space, in linear light, linear workflow. And this area here, and the connection is very important. We have normally the best translators inside of our CPUs or applications and all of that. But we need, of course, a screen that is color corrected, where we know what we are looking at, and that it is calibrated. And calibrated is, of course, one of the biggest things that we need to have, because in the moment our monitor is not really set up in terms of brightness, contrast, and color, then all of our efforts go downhill, because we have done something that will maybe not work in the quality that we like to have. I wish you, for any project, of course, a lot of quality. Thanks for listening. Have fun with it. Bye bye.